Okay, so I'm really grateful for this opportunity. I must really thank all of you for attending this webinar, despite the current difficulties all over the world. I can see so many people on this call, including very senior colleagues. So you're welcome and just listen to my presentation. So my expectation is that you have a lot to learn from today's presentation. As I was introduced, my name is Segun Fatumo. I'm currently employed as an assistant professor at the London School of Hygiene and Tropical Medicine at the University of London, as well as MRC UVRI Uganda, where I lead projects relating to genomics of cardiometabolic traits. So a component of my job requires capacity building across Africa, which I love to do with great pleasure and joy. So today, I'll be speaking on the presentation I've titled. Today, I'll be talking about what I've titled Unlocking the African Genomes and the Potential in African Scientists for Precision Medicine. So in the next 30 to 40 minutes, my presentation will focus on the opportunities in African genomes for precision medicine. I will start with some important background information on the burden of communicable and non-communicable disease in Africa. I will relate this to genomics and spend a bit of time on the current genomic study in Africa, with emphasis on our recently published largest genome ever in Africa. I will conclude with some potential avenues for career opportunities in genomics for African scientists. I think everybody could dive in. So this is very important because the organizer of this event, they've asked me to talk a bit about career opportunities. So for the purpose of clarity, and not to assume that everyone on this call understands what precision medicine is all about, I will start with this illustration. So precision medicine is an approach for disease treatment and prevention that take into account individual variability in gene, environment, and lifestyle for each person. So this approach to medicine is in contrast to the current standard one-size-fits-all approach, in which disease treatments and prevention strategies are developed for the average person, with less consideration for the difference between the individuals. As you can see on this slide, the big box on the left show the patient population. So this indicates that patients do have different genetic composition and they are exposed to different environments. The standard one-size-fits-all that we are all used to assume that all patients are the same, have same genetic composition, and are exposed to the same environment. So the same treatment A is administered to all. The implication of this is that such treatment is not effective for many patients. So a tailored approach will group the patients and administer an appropriate treatment for each group. For example, treatment A could be appropriate for Africans living in Africa, treatment B for Africans living outside Africa, treatment C for Europeans, treatment D for Asians, and so on and so forth. So therefore, precision medicine is an approach to detecting and treating. Okay. So the precision medicine approach is an approach that is used for detecting, treating, and managing disease that is based on individual variation in genetic, their environmental, as well as their lifestyle factor. Maybe you already know that our gene play a role in the occurrence of infectious disease like tuberculosis and HIV/AIDS, as well as some non-communicable disease like cancer and diabetes. So a very quick question to ponder on is, why does COVID-19 make some people so sick and many who are infected with COVID-19 will not even have symptoms or may not even know? I think you should ask your gene. Why did I, as a person, have never had malaria, despite being exposed and being bitten by mosquito, and others do have malaria regularly at every mosquito bite? You should ask your gene. The point I'm trying to make here is that our genes do play an important role in our predisposition to disease, but there are other factors such as our lifestyle and as well as environment. It is no news that in sub-Saharan Africa, communicable disease such as malaria, tuberculosis, and HIV have long been among the most prominent contributors to disease burden. Sub-Saharan Africa is the only region of the world in which infectious disease still outnumber chronic disease as a cause of death. Apparently, several studies found a very strong positive relationship between Earth GDP growth. For example, one study showed that a 1-year increment in life expectancy was associated with 4% increment in GDP. For example, in 2007, when I was a PhD candidate and I was actively working on malaria, I remember that every presentation I made at conferences always starts with a statement: malaria kills 3 million people annually. So here on this slide are two papers I published in 2007 indicating the extent of the burden of malaria. So the graph on the bottom left showed that up to 2005, childhood mortality due to malaria alone was more than 800,000. But the good news is that there has now been a continual decline in prevalence and mortality due to malaria and other infectious diseases. Currently, malaria kills about 400,000 people globally and still remain a major public health problem in Africa. But comparing to my previous slide, you'll have noticed a significant reduction in mortality due to malaria. Apparently, this significant reduction in mortality has been seen across different infectious diseases in Africa. So the big question is, what has changed? So why the big reduction in the mortality due to malaria and other infectious diseases in Africa? There are so many factors that have contributed to the decline in the mortality due to infectious disease, including increase in research funding. But this slide attempts to show you one big factor. As you can see on the upper map in this slide, it shows the estimate of world malaria burden in 1995, while the map below shows the estimate of world poverty in the same year. What you'll have probably noticed is that where there is extreme poverty, there is abundance of malaria. Several studies, including one prominent one that was published in Lancet, found a strong link between malaria and poverty. One paper showed that wherever malaria occurs, the poorest children are twice as likely to contract malaria than the least poor children. Fortunately, the World Bank projection has shown a sign of improvement in the extreme poverty in sub-Saharan Africa, with the hope of ending extreme poverty in 2030. Probably one factor that has contributed to decline in extreme poverty is increased urbanization. Even though up to 60% of Africans still live in the rural area, in this slide, you may have seen that level of urbanization has significantly increased in the last 60 years. So people move from the rural area to the urban area. So with the rapidly increasing urbanization in Africa, the trend towards healthy diet, obesity, and increase in metabolic risk factor. Unfortunately, non-communicable disease such as type 2 diabetes, cancer, they now present even greater threats as part of a broader epidemiology transition from infectious to non-infectious disease. Although the burden of the disease in Sub-Saharan Africa continues to be dominated by infectious disease, countries in this region are undergoing a demographic transition, leading to increasing prevalence of non-communicable disease. Like I can see from this graph, we will see a decline in infectious disease. We will see an increase in non-communicable disease. So the World Health Organization projected that the burden of NCD might even double in Africa by 2030. So as Africa continues to in the decline of infectious disease, unfortunately, the burden of NCD continues to increase and much higher than other parts of the world. The projected increase in the prevalence of NCD may even be greater in Africa compared to developed countries. Collectively, WHO estimates that NCDs will rise by 27% over the next 10 years in Africa, compared with a global rise of 70% over that same period for other parts of the world. Looking at the top 10 global causes of death, there are mainly non-communicable disease, as you can see in blue, and they remain the leading causes of death in the last 15 years. Interestingly, at least 9 out of 10 leading causes of global death have genetic components. What this means is that genetic knowledge and application to diagnosis and treatment, they play an important role in identifying solutions to leading causes of death. If precision medicine will be effective and benefit all, representative genomic research has to be undertaken. A review paper that was published in 2016 revealed that 96% of participants in genome-wide assessment study, GWAS, were individuals of European descent. 7 years on, in 2016, the findings indicate that the proportion of individuals included in GWAS who are not European descent has increased to 19%. But much of the increase that you see as a result of more study is due to people from the Asian population. The degree of which people of Africa are represented in GWAS has barely shifted. The finding prompted warning that a much broader range of population should be investigated to avoid precision medicine being of benefit to a merely privileged few. Even up to last year in 2019, about 79% of all GWAS participants are still of European descent. Using primarily white European population to draw broad conclusions on precision medicine could be misleading and aggravates health disparity. As we have noticed on this slide, the fraction of non-European individuals in GWAS has stagnated or declined since late 2014. And this suggests that we are not on a track to correct the imbalance. This is especially problematic as previous studies have shown that African studies contribute an outsized number of associations related to study of similar size in European. In this presentation, I will show you an example of such genomic study in our Uganda and other African population. I like to bear in mind that the continental European represent only 10% of the world population, and all individuals of European descent worldwide only make up about 16% of global population. I think that there's an urgent need to expand the diversity of population being studied in GWAS for a more complete and effective precision medicine for all. As you can see on this slide, governments of over a dozen countries have invested heavily in establishing national genomic medicine initiatives, from Saudi Arabia, Qatar, Turkey, Brazil, Japan, even Estonia, with a population of only 1.3 million people. Just a few months ago, the Prime Minister of the United Kingdom, Boris Johnson, announced an investment of £200 million to do whole genome sequencing of up to 500,000 individuals in the UK Biobank. which will represent the world's largest genetic project to be sequenced. In 2016, the Chinese government announced a bold initiative to become a global superpower in precision medicine with an investment of 9.2 billion US dollars. So the Chinese initiative has three components to focus on recruitment as well as the other components of cardiovascular disease. So the Chinese $9.2 billion precision medicine initiative could see about 1 million whole genome sequence by 2013. Of course, many people are familiar with the American project that is called All of Us, which aimed to enroll 1 million participants when completed in 2022. All these country-level initiatives are an important part of the global effort for precision medicine. I don't know, did you notice that there is no known national initiative from any African country? The well-coordinated H3 Africa initiative is funded by United States NIH and United Kingdom Wellcome Trust and not a national initiative. In a precision medicine paper published in 2018, we focus on type 2 diabetes. It was evidence most of the country-level initiatives are public-private initiatives, including the UK Biobank project and United States All of Us project. The only exception on this slide is the Genome Aggregation project in Sweden, which is public initiative, the Estonia Personalized Medicine pilot project, and the Saudi Human Genome project. So this gives some hope that genomic researchers within Africa may want to look beyond government funding, which will not even be available. So this is so important because of the importance of the African genome for precision medicine. About 100,000 years ago, humans migrated out of Africa and started to populate the globe. So they carry with them part of their ancestral genetic variation, implying that all humans have a genetic origin in Africa. What this means literally is that everybody came out of Africa. So given the central importance of African to human origin and disease substitutability, there's a clear scientific and public health need to develop large-scale efforts examine various diseases in population of African descent. African population are known to harbor the greatest genetic diversity, emanated from an estimated 2,000 distinct languages group, 3,000 different ethnic groups, and people speaking different language and all that contribute to the reason why we have so many genetic differences. In order to demonstrate the value in African genome, we recently published our work in Cell. This project represents the largest collection of GWAS and whole genome sequence data in Africa. We collected and analyzed genome-wide data from 6,400 people from rural communities in Uganda. We also incorporated data from other parts of Africa, including data from Nigeria, from Kenya, and South Africa, making a total of 14,000 individuals across Africa. We measure a range of communicable and non-communicable health diseases, such as HIV, hepatitis B and C, BMI, liver function, food blood count, HbA1c level, and so on and so forth, which is an indicator that is used to diagnose diabetes. In the next slide, I will show you some pictures from where the data were collected and the settings of which the data was collected. So this slide attempts to show you the procedure that we took in the data collection stage. Approval for the study procedure includes material transfer agreements were given by UVRI and the Uganda National Council of Science and Technology. So the community mobilization proceed the recruitment process and focusing on engaging with participants at both community and individual level. Local leaders are first sensitized about the study activities and their permission sought before holding community meetings. Community mobilization was followed by mapping, then the census and medical survey for health, for lifestyle, for biophysical and blood measurements to ascertain disease outcome and risk factor for selected participants. So 5,000 individuals were recruited for the genetic epidemiology study, and 2,000 individuals were recruited for whole genome sequencing. So in our pilot data collection, we find a high prevalence of cardiometabolic risk factor in our cohort, which has average age of less than 50. We also noted a very low awareness of disease status. For example, none of those with high cholesterol was aware, and about 80% of those with high blood pressure were not aware. You can also see here that more than half of people with HbA1c, that is more than 6%, were not aware. So this really called for concern. As part of this project, support in terms of treatment were given to research participants. Also observed in this project is comorbidity of communicable disease and non-communicable disease. Some with abnormal liver function also have hepatitis B and C or C. So the message from this cohort is that there is relatively high prevalence of risk factor of cardiovascular disease for a young African population when 90% or maybe close to 90% of the population is less than 50 years of age. 22% prevalence of hypertension is high. 31% prevalence of central obesity in women is really high. Like I said previously, more worrisome is the low level of awareness of this condition coupled with low access to care. This is especially important, bearing in mind that about 60% of Africans still live in similar rural settings, as only 40% of Africans live in urban areas. Though many of this may sound like a very challenging situation, but this cohort offers a rich platform to investigate interplay between communicable and NCDs. We have the opportunity to create health awareness, which is in turn may further narrow health disparity. First, between the rural and urban community within Africa, and between Africa and the rest of the world. I think Africa is still more receptive to research, as it is not too complicated to recruit people and get them motivated to participate in research compared to what you will see in other parts of the world. So this cohort provided us with opportunity to build capacity at different levels. So like I said, we genotyped 5,000 people on a 2.5 million Illumina array. So this was the most dense array at that time. I know that if this were to be genotyped today, it will probably be genotyped on the H-Africa chip array or similar Africa genotyping array. So whole genome sequencing was done in 2,000 recruited individuals. So we performed stringent quality control, and and also the quality control for the whole genome data set, and they were made together. So in the study, we incorporated data from the Durban diabetic cohort, the African American diabetes cohort to make up 14,000 people. We discovered 10 novel genetic associations with several traits and disease. None of these genetic associations are only found in Africa and would therefore not have been found in the largest study involving European individuals. So we demonstrate the value of African genome resource by creating an African unique reference panel using data set from our 2,000 whole genome sequence, including data from African Genome Variations project and the 1,000 genome project. As you can see on this slide in the figure on the top right, so our unique imputation reference panel outperformed a 16 imputation panel in accuracy, especially when we input them into East and South African population. The matter plot below further show the power of imputation to identify more genome-wide significant variants when genome-wide association study was done with or without imputation. So this slide shows the list of novel genetic associations that were found to be associated with various cardiometabolic traits and disease. It also shows lists of distinct associations at already known loci. As you may have noticed on the last column of this table, the minor allelic frequency of most of the variants are at either zero, the last one here, for the European population, meaning that these variants are monomorphic or very rare in the European population, which means that in the study that involved even 1 million or more than 1 million people in the European population, they will not have been able to find this because they do not exist in the European population. So our discovery include a genetic variant that causes alpha thalassemia to be associated with HbA1c, an indicator for diagnosing diabetes. Genetic variant is represented, this particular variant is represented in 22% of Africans and almost absent in the European population. This particular variant is thought to have become more frequent among African population because it can prevent severe malaria. So our findings suggest that as HbA1c level are often used to diagnose diabetes globally, it is possible that diabetes may be diagnosed in up to 22% of Africans based on their genetic composition. Our study also leveraged on the lower linkage disequilibrium in African datasets. Our pharmacopein analysis resulted in a narrow, credible interval for most traits. In fact, we were able to map 16 out of 41 distinct loci to a single SNP in the credible interval. We also resolved the previously identified association with HbA1c. I think that this is one of the big values for using African genome resource. As you may expect, we found a high level of genetic diversity in the Uganda population that is seen than what you would expect in a study of Yoruba population. In fact, around a quarter of the genetic variants identified in our Uganda dataset has not been discovered before. We found that 28.7% of SNPs discovered in Uganda whole genome sequence dataset are not found in the genome aggregation database. Specifically, we identified 9.5 million novel variants that are not present in the 1000 Genome Project Phase 3, African Genome Variation Project, and the UK 10K reference panel. So the richness of the Uganda Genome Project also offers us the opportunity to study the extent to which genetic differences and differences in traits and disease. We assess the heritability for all the 34 traits using a mixed model approach. We found that height is less genetically determined in Uganda relative to what you will see in the European population. So the narrow sense heritability for height was 49% in Uganda compared to estimate of 70 to 80% in the European population. So one reason for this might be an environmental factor, such as nutrients in Uganda. In contrast to that, the heritability estimates for LDL were significantly higher in the Uganda population compared to the European population. What I'm saying is that genetics contribute more to height in Yoruba population than what you will see in African population. On the whole, our findings highlight the usefulness of examining genetically diverse population within Africa. We now need even more and more large and more diverse study of genetic causes of disease across Africa. Collectively, findings may foster the development of new treatments that may benefit people living in Africa, as well as people of African descent living around the world. So just to recap, African Genome Resource provide opportunity to provide novel genetic loci that are specific to African population, which may have implications for precision medicine. As you have seen earlier, there's a great value in using African Genome Resource for generating African unique reference panel. Also, the lower linkage disequilibrium in African compared to other populations provide the opportunity to narrow in and find map disease loci. And of course, African genetic resource may help with African specific diagnosis of disease. So for those who might be interested in reading more, so here on this slide, you will see some very interesting paper you can read or article that you might read that give a very good summary of our work, including a complementary that was published just last month by eBiomedicine, which is published by Lancet. So currently, the number of sample size from Africa is relatively small. I've said to you that we published a paper that was considered the largest genome ever in Africa. That study only includes 14,000 compared to millions studies that have been done in the European population that include millions of people. So the sample size from Africa is still relatively very small. In previous slide, I demonstrate the value of genotype imputation for improving power to detect association. Other strategies to boost power include multivariant GWAS or recruitment of large sample. Like you may have already known, GWAS analysis are generally univariant in nature. So what that means is that it focuses on analysis of a single phenotype with SNPs. However, that many human traits are highly correlated. For example, LDL and HDL are correlated. Height and weight are highly correlated. White blood cell and red blood cell are highly correlated. So this correlation can be leveraged to possibly improve power of genetic association tests to identify markers that are associated with one or more of the traits. So the focus of my research group for the next 18 months is mainly multivariant GWAS. We'll continue to leverage on great collaboration that we have within Africa to support students in order to build capacity so that they'll be able to analyze large-scale genomic data while we wait for the wave of data to be generated in African population. So our focus will be capacity building and, for the next 18 months, and it's going to be on multivariant GWAS. So last year, we published the first ever multivariant GWAS or full blood count. We used different multivariant methods to boost power and identify 3 known and 5 novel loci that were not identified using both standard univariant and also other multivariant methods. So currently, two of my MSc students are working on applying different multivariant methods of correlated traits. Ture, for example, who is from Mali, is exploring different African and African American data sets, including black participants from UK Biobank, to discover potential genetic loci for the 4 blood lipid traits and use multivariant method. Similarly, Brenda, who is from Nigeria, also is using the same method and similar data set to explore understanding of genetic of hypertension in African ancestral population. So the ultimate is to have a representative, diverse population inclusion in the implementation of precision medicine for it to be effective and beneficial to all. In Africa, a few ongoing initiatives, such as the H3 Africa that I mentioned previously, and the Nigerian 100K non-communicable disease genetic heritable study, that's a NCDGHS, could provide data to improve the evidence base and make genomic medicine useful to diverse population. I'm really excited about the recent establishment of the Nigerian 100 Genome Project, in which I'm playing a leading role. So the big question is, who is going to refine the African neem oil? Who is going to refine the African neem oil? Maybe you have heard about the statement from Clive, who say that data is the new oil. Not quite long ago, James Bridle re-echoed this, why he said, data is not just the new oil. Data is the new nuclear power. James emphasized that data is a valuable, powerful commodity, but unlike oil, it is unlimited to quantity and its capacity to harm. So a statement from my recent presentation says that it is time for Africa to look beyond oil. The African genome data is a great resource for now and the future. So like I said, so who is going to refine this new oil that we have? I assure you that a time is coming, not very long from now, when your son or daughter is born in the hospital. The doctor will not only give you their birth certificate, they will also give you a disc which contains their genomic sequence. The implication is that at birth, you could have an idea of any potential disease that your son or daughter may have. What I mean is that if you already know that a child has, they are likely to have diabetes at 45, and you already have that information, that might help you to be able to plan them, be able to make them to adjust their lifestyle so that they will not be able to have that particular disease. So data, again, is very big. And this slide is showing you if you print the human genome, just one person, print their genome. So you have like up to 40 boxes just by printing just one human genome. This is even big on a computer, talk less of you printing it down on a paper. So that should explain the reason why there's now high demand for genomic analysis or data analysis in general. As I've been advised by the organizer of this event to talk about how people can dive into career opportunity in genomics, I know that there are so many hindrances or so many barriers why you don't have so many people refining the new data. Like, for example, in Nigeria, the oil sector, we have the crude oil, and the other people refine our crude oil for us. The same thing also with other part of Africa. They have these great natural resources, but they don't refine them. We're now in the era of data. So we should be ready to refine our data so that in the future, the publication that come, the procurement that is being done will not be done by people that do not contribute to the data. So I understand there are so many challenges that we face in Africa. And many of them that have been told by so many people that sent me an email or asking for one thing or the other is there's a lack of mentoring, lack of resources, and lack of funding. There's limited training opportunity at home for people that actually want to learn. I understand all these challenges. But my answer today is that African scientists need to look beyond the challenges and think more about how we can overcome those challenges. So I have just a few tips to give today. One of them is that we should look beyond our degree. We should look beyond the degree. Maybe you have a degree in biomedical science, or you have a degree in microbiology, you have a degree in whatever. They don't really matter again to the multidisciplinary work that is being carried out in the real world. Many people, when I give presentation, tend to ask me, oh, where did I do my degree? Where did I get my genetic study from? Many of them did not know that I, for one, for example, never attended any genetic class in my life. I did not have a degree in biology. I did not have a degree in genetics. I did not have a degree in biochemistry or my first degree, my second degree, my third degree were all in computer science. But there's need for us to have a new attitude to learning. Anything that is worth doing has to be done well. You have to think about what is it that you want to do as a person, and what are the new opportunities that are there for you to learn. It is not all about the degree that you have. It is not all about the university that you went to. It is not because you have the opportunity to go to Harvard or to go to Cambridge or to go to Oxford or to go to the best university in the world. Maybe you never have that opportunity, but you have the intention to do whatever you want to do and change the attitude to learning. I, for once, never study abroad. I never studied in Cambridge or in Harvard. I had my first degree and my second degree and my third degree in Nigeria because the reason why I'm saying this is because many people that approach me, they approach me with the mind that, oh, maybe you have opportunity because you have access to study abroad. You have access to all the resources abroad. You have access to all the expert abroad. That is why you are able to do what you are doing. But that is not true. My first degree was Nigeria. My second degree was Nigeria. My PhD was Nigeria. I don't know if anybody here ever heard about Agbado District Comprehensive High School, Okearo. That was the secondary school I went. Of course, you may never know that secondary school because it's not one of the prominent secondary schools ever. I don't know whether you ever heard about Osun State University, Osun State Polytechnic Ire. That was where I went. Maybe you don't know. Maybe you think that it's a low-class university. So my advice today is that look beyond your degree. Look beyond your university. It is always good. It's always a pride to say that I'm from that you are from Great Ife or you are from Great University of Lagos or UI. But the world we are in is no more about the degree that you have or where you have them from. It is all about what you know. What are the new things that you have learned? Maybe 95% of what you have learned in university, you will never use them. You have to think about new things to learn that you can apply to the real world. So that's one of my tips that I want to give today. Get a new attitude to learning, clarity of vision. Anything you want to do, you're very clear about it. This is what I want to do. I have prepared my mind for many years that wherever I live, whether I live in Uganda or I live in the UK or I live in the US or I live in Nigeria, I'm very clear that what I'll be doing is genetic analysis of African data sets. So I think it's very good if everybody can be clear about what they want to do and focus on that. Of course, there's also the G factor, the God factor, which I always like to talk about it because I'm a Christian and also this platform was organized by a Christian community. And the last one I will talk about today is the right association. If any association where people think that something is not possible, of course, it will never be possible. You have to be where something is possible. You have to be where you can achieve something. I was a member of a group of students doing bioinformatics in 2016. And that was where I had the first opportunity. So I think people should be in the right association. So based on that, I would like to recommend to you the Nigerian Bioinformatics and Genomic Network that we formed just maybe about a year or 2 years ago. So this is a network where we have so many people currently, and I know we have about 700 members in Nigeria that live in Nigeria and that live abroad, part of this. And fortunately, registration for this network is free. And you have endless information and endless opportunity that will be sent to you. So if you are here, you would like to join, why not? There's a link there where you can join. We recently have a paper accepted in about our activity. If you want to read about that, you can just be on the lookout. A paper will be out very soon, probably before the end of this month. I'd like to say that, like the host mentioned at the beginning, this year we organized the first Nigerian Bioinformatics and conference, and that was a place where I met, for example, one of my students now, Chisholm, for the first time. That was just last year, June. But out of the about 200 people that attended, she had the opportunity to discuss further what she wanted to do. She was clear about her vision. She was clear that she wanted to do a PhD. So I'm very happy to say that just between then and now, Chisholm, for example, she had opportunity. She had a fellowship, and she'll be traveling to South Africa for to execute a fellowship for a few months. She also had another travel fellowship to go to Mali to present a paper just within a few months. So the opportunity are just everywhere. Just you have to be the right person to get the opportunity, and also have the right people. Again, a few years ago, I was doing a workshop in Nigeria, in Abuja, and I met Brenda, who's also my student now, my MSc student. And Brenda attended the workshop that we organized among about maybe 40 people or 30 people. So she also showed interest. And today, Brenda got a fellowship to study, to do a master degree at the University of Mali for free. So, but there were so many people there, but she was the one that was able to grab the opportunity that were available. And the same thing with other people. Ture, presently, also is also my MSc student currently. He's also have a fellowship currently in the US, trying to also learn Martin. He's been in the US for about 2 months now, and he will be there for a few months before he goes back to Mali to complete his MSc. And that's what the point I'm making is that the opportunity are there, but everybody has to just be the right candidate and be clear about what they want. And the same thing also with Mariam also. We are also currently looking for opportunity for Mariam also to build capacity. So in conclusion, there's considerable progress have been made globally in a push to implement genomic medicine as a crucial part of personalized medicine. However, African ancestry population lag behind because of limited participation in genomic research, both as research subjects as also as research investigator. So this limitation have resulted in a poorer evidence base for genomic medicine in diverse population. So while more research is needed, several ongoing projects like H3 Africa, like the 100K Genomic Project in Nigeria, they could provide data to improve evidence base and make genomic medicine useful to diverse population. Our findings from a very small data set show a great potential to inform genomic medicine, not only in Africa, also for globally. So I'd like to thank so many people that have contributed to the work I've been doing in the last 5 years or more, and everybody on the paper that we published, and so many people are not able to mention them. So thank you and God bless. I'm happy to take any question.
Thank you very much, Dr. Segun. that was an inspiring presentation. And I think it's more than just a presentation, it's also a challenge to African scientists on board. So while you take a short rest from your talk, there are some questions have started coming in. So we encourage people to ask questions. We are very sorry we took more than 40 minutes. So, but nevertheless, we can still manage the time. So we have approximately 10 minutes to go. So, Dr. Segun, are you ready to take questions now?
Yes, I'm ready.
Okay, thank you very much. Someone was asking a question about your research. He said, can two SNPs, that's single nucleotide polymorphisms, that are 83 base pair apart, not be linked? I mean, R square is equals to 0.014.
Okay. That's a very interesting question. I think for our own study, we always look at anything that is more than 1 MB apart. So we look at 500 KB on the right and 500 KB on the left. So we always make that assumption that anything within that region, they are in naked disequilibrium.
Okay. I think you already did justice to that. So several people are also asking as well that how can they reach you, and how do they partner with your research group, and as well can you provide mentorship? I just try to summarize those set of questions altogether. So anybody who wants to know about your research group and who wishes to partner or receive mentorship.
Okay, so I'm showing a slide now. That's the first slide. That's my email. You can follow my work on Twitter, and I'm also available on Skype. But beyond that, in the last 5 years, I've received email from people that are interested in research, mentorship, and support almost every day. People saying that, okay, I do this for me or do that for me, which is fine. And that's one of the reasons why we established the Nigerian Bioinformatics and Genomic Network, so that we can give information to people at the same time, so that we can support people at the same time. Nevertheless, I'm happy to receive any email to be any specific information anybody have, and to discuss further with them. But the network that we have is a very good platform to disseminate information to people. Maybe I didn't mention we are planning to have a second conference. It will likely going to be in Abuja, and this also will be an avenue to meet so many people and many people and discuss research opportunity with them.
No, thank you very much. I think a lot of people really want to know about how they can connect with you after now. So I think you really did justice to that. Okay. Personally, from me, I also have some questions for you. So I wanted to know the most, because yeah, you talked a lot. You talked about some of the barriers, some of the challenges we are facing in Africa. But I wanted to know the project in Uganda. It was a success, right? So what do you think was the most important thing to your success in Uganda?
Yeah, I don't know if I have any success because, like Apostle Paul said in the Bible, it's I see myself as still as striving and trying more and trying more. So that's where I see myself. I'm just trying to achieve more and do and put my best. But what I would say is that for anybody to be successful in anything, we have to be very clear about what you want to be successful about. There was a man that was talking about if you are playing football and you don't have a goal post, so how do you know whether you win or you don't? So it's very good to have a clear goal. This is what I want to do. Maybe I don't know whether some of my students are on this call. They will tell you that this year everybody is clear about what we want to achieve in the year, what each of them need to achieve in the year. And that goal that we wrote for our group, we circulate to them every Monday morning. We send to them every Monday morning that this is a goal. You have to let that stick to your mind that this one want to achieve. I think that's very important for me. If you see my office, I always pay something every around to say this is what I want to achieve. The reason is because I want to put my mind to it, because it's very easy to get lost in the thought process and forget, and because of many challenges, you forget what you want to do. So I think people should be very determined about what they want to do and stick to it until they get it.
Thank you very much. I appreciate that. So yeah, for those of us that are asking about the presentation, the webinar is being recorded. So for all of us that registered our mail on the Google form that you used to register, so you will receive the link to the video. It's going to be recorded and sent to YouTube, so it will be accessible to everyone. So don't worry, we will send the recordings to you after now. So is there still any other presentation? Any other question rather?
Yeah. Sorry. Good afternoon, sir.
You are supposed to use the chat room, please.
The chat. Oh, okay.
Okay, so yes, Dr. Segun, I also wanted to ask, did you also plan to the data from Uganda, did you also plan to incorporate electronic medical records, like to incorporate that kind of data into electronic medical records?
Yeah, currently we have the genomic data. We have not incorporated electronic record to it. I would love to do that.
Okay. Thank you very much. So the other person that wanted to ask some questions. Okay, someone wanted to know, he said, This question is really funny. I really do not get it. But he was asking about what other startups like 54 Gene. I don't know. Please, can you rephrase your question again?
Sorry, good afternoon. Please, I don't know if I can just be permitted to ask my question via.
Okay, just go ahead. I'm hearing you.
Yes, good afternoon. So, thank you for the presentation, sir. I'm David Enoma. So, I wanted to ask just a few questions. Then, firstly, the imputation, because in my area, I may be working towards the area of GWAS. So, I wanted to find out how the current work that has been done, because most studies in African populations are underpowered. So I don't know how well viewers can go on in terms of improving the imputation panels. I've learned of H3 Africa that they have a panel. So I wanted to know what's done in that area. Then secondly, the area of precision medicine versus drugs. So let's say, okay, because in my area is in cancer research. So I wanted to know if we are for precision medicine, and eventually precision medicine is going to choose drugs that are going to be used to treat the diseases. So the precision medicine approach compared with the standard drug similarity. So let's say eventually precision medicine chooses a particular kind of drug. So is it not, how do we compare it side by side with another approach wherein you just use similar drugs instead of going through the...
I get a question. Maybe you're not there at the beginning. My first slide actually explained that.
Okay.
For example, here, maybe we are like 100 people. If you're like 100 people here, we don't have the same genetic composition.
Yes.
What precision would do is if people that are AS, everybody in Nigeria knows that AS or SS, or maybe you understand that the reason why some people don't normally have malaria is because of their genetic composition. Like people that are AS, like myself, don't really have malaria like people that are AA. So, like, if somebody have diabetes, you have to take into consideration their genetic composition before you administer drug, instead of administer only one drug to everybody. So that's what I will answer that question. And if you go back to the first slide, you will see that I explained that in the first slide. Second question is about imputation. So they are now we have a reference panel from Uganda that perform very well for African population that can be used. And maybe other people also are building reference panel in Africa, which is good because 10 years ago, there were nothing like that in Africa. And now there's also H African chip that can be used. So things are really improving, and we should leverage on that.
Thank you very much, sir. Yeah, so I had one last question. Sorry. So, like, there is a work I heard about African genomic startups, just as like 54 Gene, the one done by Dr. Abasi. So I would like to know, like, what opportunities there are in terms of building products that can have commercial value around African genomics, either at NGO level or at commercial level, like opportunities. I saw the I mentioned, at least for the first time I heard the NCD GHS work. That's the 100K NCD project, which is a great initiative. I wanted to know, like, what other initiatives could be there, I mean, in terms of African genomics and in the area of startups. Thank you.
I think that question has to go to Abasi. I know Abasi very well. We work together on the consortium that we recently established, and the company that he started has so many components, and one of such components is to support research, and which we are taking lead in that particular area. I know they also have other things they do, but I will not go into that because I'm not an employee of 54 Gene.
Okay, thank you, Doctor. We are running. We have run out of our time. We may not. Oh, Doctor, will you be able to take one more question?
Yeah, yes.
Okay. So someone wanted to know why there is what is the reason for genetic diversity in Africa, in the African genome. So why?
Okay, I think I've explained that also.
Exactly.
Yeah, but I can. There's no. First of all, everybody came from Africa, so that's one reason. And there's a slide where I show that everybody came from Africa, and also there's if you look at the diversity in Africa itself. If you look, okay, let's not talk about Africa. Let's talk about Nigeria, for example. Nigeria is so diverse. People speak up to 500 languages, different languages. Apart from the main languages, the Yoruba, Igbo, and Hausa, there are also several languages across Africa, which also contribute to diversity. The tribes are different, the ethnic group are different. So all those things contribute to genetic diversity.
Okay. I think someone is also asking something similar. So I don't think you have answered that rightly. Okay. Okay, for the person asking about the bioinformatics network, as part of the mail I will send after now, we will send how you can get access to the Nigerian Bioinformatics and Genomics Network. I'm also a member of the platform. I attended the conference last year as well. So but the take home for today, I think, should be that we should all get our gears on, and we should be ready to explore this oil, the data oil, which we've been exposed to today. Thank you, Dr. Segun, for honoring our invitation. We sincerely appreciate this. It's an exceptional opportunity to have you to speak with African scientists, upcoming ones at that. Many of our participants are very young, and we realized they had interest in genomics and bioinformatics. So we really appreciate this opportunity that you've granted us to speak to us out of your tight schedule. And I knew I was really on your neck, but thank you very much. Thank you very much, sir.
Yeah, thank you very much. I know that many people on this call are young, but I like to. I've seen so many senior persons here. I can see Professor Olumide Owolabi and other people on this call. I want to thank you very much for coming, and God bless.
So thank you very much. If you have been inspired in a way by this webinar, we would like you to share some. We would like you to drop a tweet on our official Twitter platform at CMESBAHF, on Instagram as well, and we also have a website if you wish to know more about the Christian Medical Scientists and Basic Health Foundation. So if you don't forget as well to also tag Dr. Segun, who is the speaker, alongside with your tweets. So we thank you very much. So on behalf of the CMESBAHF Board of Directors and the National Executive, we say a very big thank you to everyone who honored this invitation, and then we say a very big thank you. So now we'll be saying bye to everybody. Thank you very much for attending our webinar.